Morning, everybody. Happy Monday. Hope you all had a good weekend, or as good of a weekend as we could have. I've been getting some questions from some of you on central angles and finding arc length using circumference and things like that. I wanted to just address that kind of and connect it with some of the work we've already done, because I think if you can see the connection between this new concept with that old concept, it'll help clarify things for you. So, and it also pertains to the area, sector area. So it's the same thing, similar to what we've been doing, but it looks a little different. So here we go. Here's a sample problem. Circle D has a circumference of 26 centimeters. Given a central angle of 70 degrees, find the arc length of minor arc AB. So here's circle D, here's A and B, the central angle 70 degrees. Now, minor arc is just another way of saying an arc length with a central angle of less than 180 degrees, as opposed to, say, a major arc, which would be an arc length which is a central angle greater than 180 degrees. So it's a way you can talk about any arc with just 2 points. So minor arc AB, major arc AB. This little vocab for us. So we're gonna answer this question in just a second, but first let's visit our geometric sequences that we played around with, because there is a direct connection between what we've done and this new material. So here's a sequence, a geometric sequence: 3, 9, 27, 81, 243, and so on and so forth. And if you're looking at it, you can probably see pretty quickly that we're multiplying by 3 every time. Right, so we do times 3, times 3, and so on and so forth. So, what does this have to do with central angles and arc lengths? Well, it's all about ratios, people. So if we look at this, 9 over 3, the ratio of 9 divided by 3, is going to be the same as, say, the ratio of 81 divided by 27. In this case, they all equal 3. And it's also, you could also keep it, you could look at it another way. The ratio of 27 to 3 is going to be equal to the ratio of 81 divided by 9. In this case, they both equal 9. Oh, and I didn't finish this one up here. This one is, both ratios are 3. And so, and it doesn't matter what the units are on this. If this was, say, 9 centimeters to 3 centimeters, that ratio would be the same as if this were 81, inches to 27 inches. The ratios are the same. It doesn't matter about the units, but the ratios are the same. So what does that mean for our work up here? Well, it's all ratios, people. It's all ratios. The arc length, which is the portion of the circumference, compared to the whole circumference, is going to be equal to the central angle out of all the angles, the total sum of angles in a circle. And so it's just setting up a proportion. So in this case, the arc length is something we don't know. So we'll put arc AB divided by the circumference, which we know is 26, equals, I don't want to do it on the floor, my wife will destroy me. Let's see, is equal to the central angle, in this case it's 70 degrees, divided by 360 degrees. And again, the units don't matter, because as long as the units are the same here and the same here, we should be okay, because the units would cancel out. And then we just, in this case, let's see, we want to figure out this numerator, so we want to clear the denominator by multiplying by 26. And think about what's happening here. This is 70 degrees divided by 360 degrees, so the units of degrees would cancel out. And this 26 refers to 26 centimeters, which means our answer will be in centimeters. And this gives us a length of 5.05 centimeters. And I'm just going to truncate that. It says it ends up being 5.05555. I'm just going to truncate it, just cut it off, not even round. So it's about 5 centimeters for minor arc AB. So it's all ratios, people. It's all proportions. Keep up the good work, people. Keep up with the exercises. And as always, if you have a question, shoot them out to me. I got time, and I'm here for you, so shoot me an email. Oh, this is not an advertisement for Clinique. I'll just cover that up. There you go. All right. Have a good one, people. Bye.